Welcome to the deep dive. We're jumping right into the deep end today, and we are talking directly to you.
Yes, you.
Yeah, the person listening to this who just absolutely refuses to be left behind, the person who is, always looking for that operational edge, and the one who is completely determined to master what has undeniably become the ultimate non-negotiable skill of 2026.
AI-assisted development.
Exactly. AI-assisted development.
It really is the defining skill of this entire era.
Yeah.
I mean, if you don't understand how to wield these tools right now, you are essentially trying to build a skyscraper with a hand trowel, while everyone else is just, sitting in the cab of heavy machinery.
Right.
And we aren't just going to give you a surface-level overview today. We're going deep into the actual mechanics of how this software works.
Which is why our mission for this deep dive is to take you through what we're basically calling the Claude Code Master Course, from zero to senior dev.
I love that title.
It fits perfectly, because let me just set the stage for you. The stack of sources, the documentation, the case studies we've been analyzing for this is just staggering. We are looking at, I think, over a dozen major recent system updates.
Dense technical tutorials, too.
Yeah, really dense tutorials and meticulous step-by-step workflow breakdowns from the top 0.01% of power users in the world.
And to be clear, we are going to cover the entire spectrum here. We are starting from the absolute basics of getting this software running on your local machine. And we are going all the way up to the truly mind-bending reality of orchestrating autonomous 16-agent teams.
It gets wild.
Teams that can literally build complex enterprise software infrastructures while you sleep.
Right, but our core objective for you today is very specific. We want to completely shortcut your learning curve. Because what we are seeing, and what the case studies point out over and over again, is that so many people are getting stuck at what we might call level 2 of AI development.
Right, the chatbot phase.
Exactly. They know how to open a browser, they know how to prompt a chatbot, maybe they even, copy and paste some code. But they hit a massive brick wall when it comes to actual robust end-to-end execution.
They do.
So we're going to unpack the advanced workflows, the hidden interface features, and most importantly, the fundamental mindset shifts you need to undergo to use Claude Code like an absolute professional.
That mindset shift is critical. It really is. Because if you approach this tool with the mental models you used in 2024 or even early 2025, you are going to fail. You just are. You have to understand the environment you are operating in right now.
Let's unpack that mindset shift right out of the gate. There was an analogy in one of the power user breakdowns we reviewed that completely reframed this for me. They said that using Claude Code effectively feels like playing life on Minecraft creative mode.
That is the perfect analogy.
It is, right. And if you think about it, that is the absolute perfect way to describe this massive transition we're in.
For sure. For those who might not play the game, explain the difference between the modes.
Right. So in Minecraft's default survival mode, you are dropped into a world and you have to do everything manually. You are physically chopping down digital trees block by block. You are mining for hours in the dark to find iron.
Worrying about your health bar?
Exactly. Carefully managing your health and your inventory. You are doing all the tedious, repetitive manual labor just to build a simple wooden house. That is traditional coding.
Typing every line.
Typing every line, worrying about a missing semicolon, completely breaking your entire application. But in creative mode, the rules completely change. You can suddenly fly. You have an infinite inventory of every single material in the game.
You don't craft, you just place.
Exactly. You just select whatever complex block or mechanism you want, point to a spot, and instantly place it. You are no longer constrained by the physics of manual labor. The only limitation you have left is your imagination and your architectural vision.
I love that analogy because it perfectly illustrates the contextual stakes of where the technology is sitting right now. We really need to look at the timeline to appreciate this.
Let's look at the timeline.
We are in early 2026. This is right around the 1-year anniversary of Claude Code's initial native release. And the landscape has completely fundamentally shifted beneath our feet. Think about where we were just 12 months ago.
It feels like a lifetime ago.
It does. We were in a reality where a really good AI coding agent could maybe hold its focus for 30 minutes. It could write a function, maybe refactor a single file, but if you gave it a complex multi-day task, it would completely lose the thread of the project.
It would just hallucinate itself into a corner. It would just start making up variables that didn't exist and overwriting your good code. I remember pulling my hair out trying to get it to remember what we did 20 minutes prior.
We all did.
Yeah.
But today, we have moved to a reality where agents are running autonomously for 2 straight weeks, orchestrating hundreds of thousands of lines of logic without human intervention.
It's insane.
To see that leap in less than 12 months, that is not a trend line on a graph. That is a phase change in human computing. The tools and the prompting strategies that you might have mastered back in January of this year are already a different generation from the workflows that are shipping right now in March.
It is moving so fast it will literally make your head spin. But, and this is a big bet, but before we get to the wild autonomous agent swarms building massive corporate infrastructure, we need to build the foundation.
Back to basics.
Back to basics. We have to start at the absolute beginning because you can't run a team of agents if you don't even know how to open the application.
Right.
How do you actually set up this workspace? Because I know for a massive chunk of our listeners, the zero in our zero to senior dev promise, taking that very first step is the single hardest part. So let's talk about the terminal reality check.
Yes. This is usually the single biggest psychological hurdle for non-developers who want to use this tool.
It absolutely is. People hear the word terminal and they immediately freeze up.
They panic.
They completely panic. They picture that intimidating, completely black screen with the plain white or green text that hackers use in movies like The Matrix. It feels dangerous. It feels like one wrong keystroke is going to delete their entire hard drive.
Which is understandable.
It is. But we have to make it clear. Claude Code does not run in a standard, friendly internet browser window with big, colorful, rounded buttons. It lives directly inside your computer's terminal. It acts as a command line interface, or a CLI.
And it is absolutely crucial to explain why this matters. Why force regular users out of the comfortable web browser and into the intimidating terminal? It comes down to agency.
Agency. Break that down.
Chatbots, the ones you interact with in your browser, they give you advice. They're consultants. They tell you how to do something. They generate text. You copy that text. And then you have to go figure out where to paste it and how to run it.
Which is incredibly tedious if there are 50 different files that need updating for one feature change.
Precisely. It doesn't scale. But Claude Code takes action. It doesn't just tell you what to do. It actually does the thing. When it sits inside your terminal, it has root access to your machine's environment.
It has the keys.
It has the keys to the kingdom. It has the power to create new folders and files directly on your hard drive. It can autonomously set up local databases. You can reach out to the internet, download software packages, install them, configure them, and navigate your computer's entire directory system, just like you would with a mouse.
But thousands of times faster.
Exactly. The terminal is the engine room of your computer. By putting Claude Code in there, you are handing the keys to the control room to an incredibly capable high-speed assistant.
Okay, so for the person listening who has never opened their terminal, how do we actually get this set up without them panicking? The tutorials we reviewed make it clear that it's actually much easier than it sounds.
Very.
You don't just open a raw black box. The best way to do this, especially if you want to actually see the changes happening in real time, is to use a modern code editor. The industry standards right now are Cursor or VS Code.
Both of which are free to download and incredibly user-friendly.
Right, free and easy.
Yeah.
So here's the exact process. You download Cursor, you go to your normal desktop, and you just create an empty folder. Let's call it My First Project.
Simple enough.
You drag that folder into Cursor to open it, and then you hit a simple keyboard shortcut. Control and the backtick key. That's the little key right above the tab button on most keyboards.
Yeah, it usually shares a key with the tilde.
Exactly. When you hit that, it instantly pops open a terminal window right there at the bottom of your screen, neatly integrated beneath your files. From there, to wake the AI up, you just type the word Claude and hit enter. That's it. You are in. The engine is running.
But before you ask it to build anything, there is a vital setup trick mentioned across all the expert documentation. This separates the amateurs from the pros right on day one.
Oh, this is so important.
It is typing the die login command.
Yes, the GitHub authentication trick. I cannot stress enough how important this is.
For those who might not be familiar, let's explain what GitHub is. Think of Git and GitHub as a highly advanced video game save state system, but for text and code.
Like saving your progress before a boss fight.
Exactly like that. It tracks every single change made to every single file. What the die login command does is authenticate your local terminal with your GitHub account. If you aren't using version control, you could lose hours of work or have to manually untangle the mess. But if you've authenticated with GitHub, you have a perfect, clean, version-controlled history. If the AI messes up, you just revert back to the exact save point from 20 minutes ago before the mistake happened.
Yeah.
It is the ultimate safety net.
It removes all the fear. You can let the AI run wild because you know you can always hit undo.
It changes how you experiment entirely.
Now, once you are in the interface, how do you navigate it like a power user? Because sitting there typing everything out manually, clicking around with your mouse, that is for beginners.
It's too slow.
Way too slow. There are specific keyboard shortcuts built into Claude Code that are going to absolutely supercharge your workflow. The first and most critical one to burn into your muscle memory is Shift plus Tab.
Shift tab.
When you hit Shift plus Tab, you cycle through Claude Code's 3 different modes. You have to understand these modes to maintain control over the AI. The first one is Plan Mode.
Plan mode is arguably where you should be spending the vast majority of your time, especially on complex tasks. This is a strict read-only mode.
Read only, so it can't touch anything.
Exactly. It is designed specifically for research, exploration, and plotting out your architecture. In this mode, the AI is physically prevented from changing any files. It is simply looking at your code base, reading your request, analyzing the dependencies, and proposing a step-by-step strategy.
It's like a blueprint phase. You wouldn't let a construction crew start pouring concrete before you approve the blueprint.
However,
The power users emphasize this heavily. Never, ever start executing until you are 100% happy with the plan the AI has presented. You negotiate the plan first.
then you move forward.
Right. Then, once you have that perfect blueprint, you hit Shift plus Tab to cycle into Ask mode. This is the default mode when you boot up. In Ask mode, Claude takes the plan and starts writing the code, but it is going to pause and ask for your explicit permission before it runs a terminal command or overwrites a file.
Usually by having you press Y for yes. Ask mode keeps you firmly in the driver's seat. It's the AI saying, I'm about to execute step 3. Do you approve?
Yeah.
But then, when you reach a level where you are fully confident in the plan and you just want the machine to go fast, you cycle into code mode.
The danger zone.
The danger zone, but also the auto-accept mode. It completely bypasses all the permission prompts and just executes the edits directly, one after another, at blinding speed.
It is incredibly efficient.
It is, but you only want to unleash code mode when you have an absolutely bulletproof plan. Otherwise, a slight misunderstanding by the AI can result in dozens of files being radically altered in seconds before you can hit the kill switch.
It's like taking the restrictor plates off a race car. You better know how to steer.
You really do.
Let's hit a few more quick power user shortcuts that the documentation highlights, because these save so much frustration. If you are in the terminal typing a long, complex prompt, maybe a paragraph of instructions, and you want to create a line break, a new paragraph, without accidentally submitting the message to the AI.
Because just hitting enter submits it.
Right. So you just hit Alt plus Enter or Option plus Enter on a Mac. It drops you to the next line safely. This sounds minor, but accidentally hitting Enter and sending a half-finished thought to an AI that instantly starts coding based on incomplete instructions is incredibly frustrating.
It wastes time and compute resources. You sit there watching it do the wrong thing.
Yeah. And what if you completely mess up your prompt halfway through?
Good question.
If you are typing a huge paragraph and realize your logic is totally flawed, you don't hold down the backspace key for 30 seconds. You just hit the escape key twice. Bam! It instantly clears the entire prompt line.
Double escape.
It's a tiny friction reducer, but when you are doing this for 8 hours a day, it really adds up.
And perhaps the most forgiving command built into the entire system is the /re command.
Oh, the rewind.
The rewind function. We talked about GitHub earlier, but this is an internal rewind because Claude automatically creates micro checkpoints before every single file edit it makes. If it makes a mistake, you just type /re and hit enter.
It's basically a time machine for your workspace.
It really is. It opens up a list of your recent prompts and actions in the terminal. You use your arrow keys to select the exact point in time before things went wrong, and then you have a choice.
Right.
You can choose to restore just the code to that exact state, or, and this is the truly powerful part, you can choose to restore both the code and the conversation context.
Meaning it forgets the mistake entirely.
Exactly. It completely erases the AI's memory of the mistake. It's as if the failed experiment never happened, which keeps the AI's context window pristine and prevents it from getting confused by its own previous errors.
I use /re constantly. It saves so much context space. Okay, let's pivot slightly, because there is this entire other dimension to the interface that is just starting to roll out.
The voice features.
Yes, this is a brand new feature currently available to just the top 5% of power users, but it represents the future of how we interact with machines. voice mode, and dictation.
It changes everything.
You type the command /voice into the terminal, and you can literally just hold down the spacebar and start talking directly to your code editor.
What is truly fascinating about this implementation is the synchronicity. It's not like the old days of voice notes where you record a memo, hit send, wait for it to process, wait for the AI to read it, and then wait for a response.
Right. The latency was terrible.
The latency has been effectively eliminated here. You hold the spacebar and you articulate what you want. You might say, create a new React component for a user profile card. I want a rounded photo on the left, a bold name on the right, and give the whole card a soft drop shadow.
And as you say that,
While you are still speaking that sentence, the code is literally streaming onto your screen in real time. The text appears as you say the words, and the AI is structuring the logic and the CSS styling simultaneously.
you are literally having a fluid, real-time conversation with your code editor. It feels like magic. But here's the massive, unbelievable financial bonus that the early adopters pointed out. Currently, the voice transcription process does not cost any API tokens.
We should probably pause and explain what an API token actually is,
Definitely.
because this is the fundamental currency of the AI economy, and it dictates everything about how these workflows are designed.
Yes, please explain tokens. I think a lot of people hear tokens and think of arcade coins or something.
It's a bit different. When you send text to an AI model, it doesn't read words the way we do. It chops text up into pieces called tokens. You can think of a token as roughly a syllable, or maybe 3/4 of a standard English word.
Okay.
So the word hamburger might be broken into 3 tokens: ham, burr, and gurger. Every single time you send a prompt to the AI, you are charged a microscopic fraction of a cent for every token you submit. And you are also charged for every token the AI generates in its response.
Which sounds incredibly cheap, right? Fractions of a penny.
It sounds cheap until you realize the scale of what we're doing.
Right.
If you are asking the AI to read an entire code base containing 50,000 lines of code just to understand the context of your simple question, you're suddenly sending hundreds of thousands of tokens.
Just to say hello, basically.
Exactly.
Yeah.
And if it writes 2,000 lines of code back, that's thousands more tokens. Those fractions of a penny suddenly turn into dollars. And if you are iterating rapidly all day, a single developer can easily burn through $50 or $100 a day in API costs just chatting with the model.
That adds up fast. So the fact that the /voice transcription itself, converting your spoken words into the text prompt, is free of token charges is a massive win for heavy users.
Absolutely. Now, for users who don't have access to the native voice command yet, the advanced tutorials highly recommend using local dictation tools running in the background. An app called HyperWhisper was frequently mentioned.
Wait, why go through the trouble of setting up a third-party dictation app just to talk to a terminal?
Because of the bandwidth of human communication. The underlying philosophy among these senior AI developers is that typing is simply too slow.
Too slow.
Way too slow. Even if you type 100 words a minute, your hands are the massive bottleneck between your brain's intent and the AI's execution speed.
That makes sense.
If you are spending 5 minutes meticulously typing out a complex set of instructions, you are losing massive amounts of productivity. Speaking your prompts allows you to provide vastly more context, vastly more nuance, much faster.
And the models love context.
They thrive on rich context. So speaking naturally leads to significantly better, more accurate AI outputs on the first try.
Speak your thoughts. Let the machine do the typing. It just makes sense. So we've got the terminal set up. We understand the modes and the shortcuts. But what if you aren't building a React web app?
Right.
What if you're an accountant or a project manager or a researcher? Does Claude Code just lock you out because you aren't a software engineer?
Actually, no.
There's a whole other side to this ecosystem. Let's look at how we break out at the terminal. I want to talk about Claude Cowork.
Claude Cowork is a fascinating evolution. It is essentially the standalone desktop application version of this underlying terminal technology.
But for regular people.
Exactly. It's explicitly designed for non-developers who want the immense organizational power of Claude Code, but applied to daily, repetitive administrative computer tasks.
Yeah.
If you think about the traditional Claude chatbot you use in a web browser as the brain, giving you ideas, summarizing text, answering questions, Claude Cowork represents the hands.
The hands of the brain.
It physically reaches into your computer's local file system, reads your raw documents, and manipulates your digital environment.
The real-world use cases we found for this are just brilliant. They are so relatable. Think about your downloads folder or your screenshots folder.
We all have one.
We all have that one folder on our desktop that is an absolute chaotic nightmare of random files with names like screenshot 2026-03-0301 at 4:15 p.m.
A total mess.
One user documented a workflow where they just pointed Claude Code at their messy, gigabyte-sized screenshots folder and gave it an incredibly simple natural language instruction. Organize this folder logically.
And the execution is what makes it feel like magic. It is completely autonomous. The AI physically scans the image files. It uses vision models to actually look at what is in the screenshot.
So it's not just looking at the file name.
Not at all. It's looking to see whether it's a digital receipt from a software purchase, a picture of a golden retriever, or a graph from a financial presentation. It understands the semantic content of the image.
That's wild.
Then it renames the file from that random date string into a clear descriptive title like AWS Server Receipt March.PAE.
Wow.
Finally, it creates a logical, hierarchical folder structure, maybe folders for invoices, personal photos, and work assets, and physically moves the files into their correct folders.
A task that would take a human being an hour of tedious clicking, dragging, and renaming takes the AI about 3 minutes.
It's a digital janitor.
Another amazing example that blew me away was the invoice processor workflow. Someone had a folder that was just a dump of random, messy PDF invoices from dozens of different freelance vendors.
Everyone has that folder too.
Yeah, right. Some were generated in Word, some in QuickBooks, all formatted differently. They told Claude Code to read every single PDF, extract the data, rename the PDFs by the date, the vendor name, and the amount owed, and sort them into monthly folders.
Which is impressive on its own, but it's what it did next that shows the power of having hands.
Right. It didn't stop at organizing the files. The AI was instructed to generate a perfectly clean, auto-calculating Excel CSV spreadsheet.
Automatically.
It read the PDFs, extracted the specific line items, and populated a master tracking sheet with columns for vendor, date, invoice number, tax, total amount, and payment status. It built the spreadsheet locally on the user's desktop. It's literally a personal administrative assistant living on your machine, capable of doing data entry flawlessly.
And this capability isn't just restricted to your local hard drive. It extends to the web as well, through the Claude and Chrome browser extension.
How does that work?
This allows the agent to navigate the actual live internet on your behalf, clicking buttons and reading dynamic web pages. The example provided in the tutorials was a content creator telling Claude to navigate to their YouTube Studio dashboard.
Okay.
The AI opens Google Chrome autonomously, clicks into the Analytics tab, pulls the relevant performance data views, retention rates, click-through rates across various recent videos, and then compiles that raw data into a fully formatted professional performance report document, saving it directly to the desktop.
So it's doing the data gathering, the synthesis, and the formatting. You just ask for the report and go get a coffee.
Precisely.
But, okay, of all the non-coding examples, my absolute favorite story from this stack of research is about the remote control feature.
The zoo story.
The zoo story. Picture this scenario. A guy is on vacation with his family in Japan. They're walking around the Nagasaki Biopark. He's literally hanging out with capybaras and monkeys.
As you do.
As you do. Suddenly, he gets an alert on his phone and needs to execute a complex task for a project. Now, normally, he'd have to rush back to the hotel, boot up his laptop, and get to work.
Ruining the vacation.
Completely ruining it. Instead, he pulls out his phone, opens the native Claude app, types /remote-control into the chat interface, and instantly and securely connects to the Claude Code terminal that is running quietly on his high-powered desktop computer, sitting back at his house in the United States.
The implications of this are quite profound when you think about workflow mobility. He isn't just talking to a generic cloud-based chatbot on his phone.
He's tunneling in.
He's securely tunneling into his own machine. He is utilizing his desktop's heavy computing resources, its massive local file system, and most importantly, all the deeply customized scripts and skills he has previously built on that machine.
Right. He was able to execute complex, multi-step tasks. In his specific case, he was triggering a custom local workflow that utilized heavy graphics processing to generate video thumbnails.
From his phone.
He initiated all of that compute-heavy work directly from his smartphone screen while standing in a zoo halfway across the world looking at a capybara. It completely bridges the gap between the lightweight convenience of a mobile device and the raw power of a customized desktop workstation.
But speaking of raw desktop power and computing resources, we really have to address the elephant in the room that we touched on earlier with the API tokens.
The cost.
The cost. If you are running massive, complex, multi-step tasks constantly, especially autonomous agents that might run for hours, you're going to eat through your token limits rapidly. The financial cost of intelligence becomes a serious bottleneck.
I have to push back here, though, because a lot of the power users are talking about a free alternative.
Yes, they are.
You're telling me people are somehow running these massive state-of-the-art models for free. Doesn't that require millions of dollars in super farms? How is a guy in his bedroom avoiding API costs?
It's a very valid question.
Mm.
And this is exactly where true power users optimize their setups. Yeah. You don't have to use Anthropic servers in the cloud. You can run local open source models entirely for free on your own hardware.
How?
The community documentation extensively details using a program called LM Studio.
What exactly is LM Studio?
Think of LM Studio as a localized app store and engine for AI models. With LM Studio, you can download incredibly capable, massive open source models, things like Quencoder 30B or the massive GPT OSS 120B, directly to your computer's hard drive.
Wow.
And once they're downloaded, you run them right on your own silicon, entirely offline.
And hooking that local model up to your Claude Code terminal is surprisingly simple, right?
Yes, very simple. You just go into Claude Code's hidden configuration file, the settings.json file. You add a few simple lines of code that essentially reroute the software.
It tricks it.
It points the Anthropic base URL away from the cloud and changes it to http://localhost:1234. Suddenly, the terminal isn't talking to the expensive servers in San Francisco anymore. It's talking directly to the free AI model running inside LM Studio, sitting on your desk.
Ooh.
Infinite, totally free coding and execution. You only pay for your electricity.
Okay, but let's be realistic about the hardware here. My laptop struggles to keep 50 Chrome tabs open without sounding like a jet engine taking off. How on earth is it running an AI model that rivals cloud servers?
That is the exact catch, and it raises a critical discussion about hardware constraints. The technical term for this is memory pressure.
Memory pressure.
When you were running local models, you weren't just downloading a file, you were loading a massive neural network into your computer's active memory. First, you have to understand the file formats.
Okay.
If you are on an Apple Silicon Mach M2 or M3 chip, you want to download models in the MLX format, which is specifically optimized for Apple's architecture.
And for Windows.
On a Windows or Linux machine with an NVIDIA graphics card, you might use the GGUF format. But the real, absolute bottleneck is your machine's VRAM video RAM, or in Apple's case, unified memory.
Let's break that down for the Zero audience. Why does memory matter more than just hard drive space?
Because an AI model isn't static data like a movie file. To operate, the entire model must be loaded into the fast access memory. A 30 billion parameter model might be 18 gigabytes sitting on your hard drive.
Which is nothing, really.
It seems fine. Most modern laptops have 500 gigs of storage. But when you launch the model, it consumes 18 gigabytes of your active RAM. And that is just to wake up.
Right, and then you start talking to it.
Exactly. When you start feeding it thousands of lines of code to analyze, that creates the context window. And as that context window fills up with your code, it instantly balloons in memory size.
It inflates.
A 60 gigabyte model on disk can easily push your system past 100 gigabytes of unified memory usage once you fill up a massive context window with a complex project.
That's insane.
So while the execution is technically free regarding API tokens, running these large local models for serious, complex software tasks requires some very serious high-end hardware. If your laptop only has 16 gigabytes of RAM, you're going to be restricted to very small, heavily compressed, less capable models that might struggle to execute complex, multi-step coding plans reliably.
So there's no magic bullet. You either pay Anthropic for API tokens to use their massive cloud supercomputers, or you pay Apple or NVIDIA upfront for a massive computer to run it locally.
Pick your poison.
Pick your poison. But either way, no matter which route you choose, you are going to be intimately dealing with this concept of the context window. And understanding that is the dividing line between amateurs and pros. Because if you don't understand how to manage context, you're going to experience what the engineering community calls the AI lobotomy.
Ah, the AI lobotomy. It is a harsh term, but it is phenomenally accurate.
Break it down.
To use any of these tools effectively, whether local or cloud-based, you have to deeply understand the mechanics of the context window. Think of the context window as the AI's short-term working memory for that specific session.
Okay.
When you open a terminal and start working, the AI starts with a blank slate. Every single file you tell it to read, every line of code it writes, every error message the terminal spits out, and every conversational prompt you give it gets sequentially shoved into this window.
And obviously, eventually, that window gets full.
Yes. And as those files and conversations endlessly pile up over hours of work, the AI begins to suffer from a documented phenomenon called context rot.
What does context rot actually look like to the user? How do you know what's happening?
It looks like the AI is suddenly getting stupid. It's a
Uh-huh.
phenomenon where the system gets so overwhelmed by the sheer volume of unstructured text in its memory that it begins to literally forget the critical instructions you gave it at the very beginning of the session. It starts repeating bugs it already fixed an hour ago. It starts completely ignoring your brand style guides. It hallucinates variables. It essentially acts like it has been, as the term implies, lobotomized by information overload.
It's like trying to hold a conversation in a crowded screaming room.
Exactly.
But the hardware and the base models are fighting back against this limitation. The documentation we reviewed dropped some absolutely staggering specs on Anthropic's new Opus 4.6 model. Are you ready to contextualize this? The new model now features a 1 million token context window.
Which is a number that is hard to even visualize.
Exactly. So to put that in human terms, 1 million tokens means the AI can hold about 50,000 lines of complex, dense software code in its active working memory simultaneously.
Which is an entire app.
It can read an entire mature app's code base in one gulp. But the sheer size of the window isn't even the most impressive engineering feat here. It's the retrieval rate.
This is the critical metric. This is what separates a gimmick from a usable tool. A massive context window is utterly useless if the AI can't accurately find the specific information hidden inside it. If we use the analogy provided by the researchers, previous generations of AI models with large context windows were like a giant, cavernous filing cabinet with absolutely no indexing system.
Just a pile of papers.
Sure, you could stuff 1 million pages of documents in there, but when you asked the AI to find one specific rule on page 400, it was essentially taking a blind, probabilistic guess. It would constantly miss the details.
But Opus 4.6 has been benchmarked with a 93% needle-in-a-haystack retrieval rate at 256,000 tokens.
It's incredible.
That means if you drop a massive, complex enterprise code base into its brain, it has near-photographic instant recall of the entire system architecture. It understands the dependencies. It knows that if it changes a variable name in the user authentication file on the front end, it might break a very specific database query hidden in a completely different folder on the back end.
It sees the whole board.
It holds the entire system state in its head all at once, just like a senior human engineer who has worked at that specific company for 5 years.
It is a breathtaking capability.
Yeah.
But, and this is a massive but, even with that incredible near photographic capacity, you still have to manage its memory carefully.
You can't just throw garbage at it.
Just because it can remember everything doesn't mean you should force it to read garbage. And the absolute best practice, the gold standard for managing this memory, is the utilization of a Claude.md file.
Let's talk about the Claude.md file. It is fundamentally your digital onboarding document for the AI assistant. It is the rule book.
The Constitution.
The Constitution. Whenever you start a new project, whether it's a coding app or a writing project, you should create a simple text file, specifically a markdown file, named exactly Claude.md, and place it in the root folder of your project. Claude Code is hardwired to seek out and read this specific file automatically every single time it boots up in that directory.
This is where you establish your absolute ground rules. It's where you define the reality of the project. You might state, we use strictly TypeScript, never JavaScript. We use Tailwind for CSS. Always use this specific brand voice for user-facing copy.
Yeah.
But there's a very specific pro tip from the top users on how to construct this file, and they call it the don't dump trick.
This is vital for avoiding that context rot we just talked about. Many beginners discover the Claude.md file and make a massive error. They take their entire 50-page corporate brand guideline document or their massive 10,000-word API technical documentation, and they copy and paste the entire thing directly into the Claude.md file.
Which is a complete disaster.
Complete disaster.
Doing that instantly clogs up the AI's premium working memory with thousands of tokens of highly specific but largely irrelevant information. If the AI is trying to fix a CSS bug on a button, it does not need to be holding the company's 15-page manifesto on email marketing tone in its active memory.
Exactly. You want to keep the Claude.md file incredibly lean, under 30 lines of text if possible. It should be a table of contents, not the whole encyclopedia.
Good way to put it.
Instead of pasting the actual guidelines directly into the file, you just tell Claude where to find them. You write a rule that says, for our specific UI design components, see the reference file located at /docs/design_system.md.
This technique is called progressive disclosure. The AI knows the document exists because it read the pointer in the Claude.md file, but it only reaches out, opens that specific document, and loads those tokens into its active context window when it is actually working on a task that specifically requires UI design knowledge.
It keeps the mind clear.
It keeps the mind very clear.
And you should use that lean 30-line Claude.md file to enforce very strict, very specific behavioral rules that save you time. Things like never use technical jargon in user-facing text, or do not use M-dashes, or always commit code to GitHub with clean, descriptive commit messages.
You're programming its personality.
You are. The real trick is evolving this file. Every time you catch the AI making a recurring, frustrating mistake, maybe it keeps using an outdated software library, you don't waste time arguing with it in the chat interface. You quietly open your Claude.md file and add a hard rule prohibiting that specific mistake. You are systematically engineering the AI to behave exactly how you want.
Now let's take this concept of AI memory and local file interaction one massive step further, because one of the case studies shared an incredibly elegant workflow that integrates Claude Code with a software called Obsidian.
Oh, I love this setup.
So good.
For those who don't know, Obsidian is an immensely popular note-taking and knowledge management app. It is beloved by researchers and developers because it doesn't trap your data in a proprietary cloud format.
Right, no lock-in.
It saves everything you write as simple plain text markdown files stored locally in a folder on your computer's hard drive.
And if we recall how Claude Code works, it is a command line tool that has root access and excels at navigating and reading local text files. The synergy here is absolute perfection.
It really is.
Your entire Obsidian vault is just a folder of text files. You point Claude Code's terminal at that specific folder, and suddenly you aren't just coding. You have an AI assistant managing your entire personal knowledge base.
It's wild to see in action. You can be talking to Claude in your terminal, and it will autonomously go into your Obsidian notes, open your daily journal file, write out a summary of what you accomplished today, generate explanations for new technical concepts you learned.
It even links things.
Yes, it automatically writes the code to create complex backlinks that connect related ideas across your thousands of notes. It organizes your brain. And tying into this is a somewhat controversial new experimental feature called auto memory.
Auto memory is an ambitious attempt by the developers to solve the session amnesia problem. Traditionally, when you close the terminal, the AI forgets the conversation. Auto memory attempts to create persistent, long-term memory across completely different coding sessions.
How does it do that?
The AI is given systemic instructions to autonomously extract facts, preferences, and recurring patterns it learns about you during a chat, and write them down into a hidden, globally accessible memory file on your computer.
So the idea is that if you spend a month complaining that you hate Python and prefer Rust, when you start a brand new empty project next week, the AI already remembers your quirks. It suggests Rust immediately.
That is the ideal outcome. But the power users had a very strong universal warning about relying too heavily on auto memory in its current state.
They definitely did. The problem is noise.
Precisely. If left completely unchecked, the auto memory system lacks perfect human judgment about what is actually important. It can quickly fill up with noise, temporary workarounds, and useless trivia.
Like what?
For instance, if you spent 3 days debugging a very specific weird error on a legacy project, the AI might commit all those hyper-specific workarounds to long-term memory. And then 2 months later on a totally different project, it starts applying those weird workarounds inappropriately.
Right, because it thinks that's how you like to code now.
Exactly. This again contributes to severe context rot.
The consensus was clear. It requires active gardening. You have to routinely open that hidden memory file and prune it. You delete the useless trivia to ensure the AI is only remembering high-signal, universally valuable information about your workflow. You are actively managing the AI's brain structure, not just talking to it.
And speaking of managing, that transitions us perfectly into the core of how senior developers operate today. Let's explore skill engineering.
Oh, this is the good stuff.
The sources were absolutely unanimous on this front. Skill engineering is the undisputed secret to achieving that mythical 100x productivity. But we need to define our terms carefully here. What exactly is a skill in the 2026 ecosystem?
Right.
Because a lot of beginners just think a skill is a really good long prompt that they saved in a Word document to copy and paste later.
That is the most common misconception. A true skill in the context of Claude Code is not just a block of text. It is a comprehensive executable playbook. It is an entire dedicated folder on your machine.
Whole folder.
Inside that folder is a skill.md file, which is essentially the standard operating procedure detailing the logic. But the folder also contains specific reference files like customized design style guides or database data schemas, and crucially, it contains MCP instructions.
This is where the magic happens. Let's unpack MCP for the audience. MCP stands for Model Context Protocol. It's essentially a standardized universal language that allows you to teach the AI how to use a specific external software tool or API.
For the Zero listener, let's explain what an API is in this context.
Think of an API like a menu at a restaurant. You, the customer, don't go into the kitchen and cook the food. You look at the menu, tell the waiter what you want, the waiter takes the order to the kitchen cooks it, and the waiter brings the food back.
Makes sense.
An API is the waiter. It allows Claude Code, the customer, to ask another piece of software like Salesforce or a weather app, the kitchen, for data without needing to know exactly how that other software works internally.
So, a skill folder containing MCP instructions might detail exactly how the AI should format its requests to navigate your specific corporate CRM software, or how to authenticate and pull raw data from a particular analytics dashboard. A properly engineered skill is a dense bundle of process instructions, specific domain knowledge, and external tool capabilities.
And because of that progressive disclosure concept we discussed with the Claude.md file, your global Claude Code installation can literally have access to thousands of these specialized skills sitting dormant on your hard drive.
Thousands of them.
Thousands. And it doesn't bloat the memory because it only reaches out and loads the specific skill document into its active context window when you type a command that triggers that specific task.
The tutorial provided a fantastic step-by-step example of evolving a basic prompt into an engineered skill. They looked at building an infographic generator skill.
Yes, this perfectly illustrates the chasm between a beginner and a senior AI developer.
It really does.
A beginner might just open the terminal and type a simple prompt. Make an infographic about the history of artificial intelligence.
Yeah.
The AI guesses at what they want, generates a generic layout, and the results are usually mediocre. But the engineered skill is a totally different beast. It has a built-in, multi-step process with dynamic QA checkboxes.
Right. When the user triggers the infographic skill, the AI doesn't just start generating, it pauses. It reads the SOP in the skill folder, and then it presents an actual interactive checklist directly in the terminal interface.
Ask you questions.
It asks the user to physically select the visual style minimalist, corporate, cyberpunk. It asks for the target platform. Is this a vertical graphic for a LinkedIn post or a horizontal graphic for an internal newsletter? It asks to confirm the core thesis statement.
It is literally acting like a standalone application. You use your arrow keys to select the checkboxes in the terminal, you hit enter, and then the AI executes the rest of the complex generation process, strictly adhering to the specific visual style guides hidden inside the skill folder. You've essentially built a custom UX design software application that lives inside a command line terminal.
Another mind-blowing skill workflow detailed in the documentation was called the spec developer skill. And this is vital because this is exactly how you avoid the trap of the AI rushing into a terrible architectural plan.
The spec developer workflow is a masterclass in treating the AI like an employee rather than a search engine.
Yes.
Typically, a user gives the AI a prompt to build a new feature. The AI quickly spits out a 150-line plan. The user, wanting to move fast, just hits accept and hopes for the best. But a power user knows that the first plan is usually full of holes, so they intentionally reject that first plan. Instead of arguing, they trigger the spec developer skill.
And when you trigger that specific skill, the AI drastically shifts its persona. It switches into interrogation mode, it analyzes its own weak initial plan, and then it turns around and asks you, the human, 20 deeply insightful, highly technical, clarifying questions.
It pushes back.
It forces you to think about edge cases you completely ignored. It asks, what specifically happens to the UI if the user's internet drops while the form is submitting? How should we handle database timeouts gracefully? What is the exact character-by-character error message we want to display here?
You have to answer them.
You answer those rigorous questions, and the AI takes all of that new, dense context and generates a bulletproof 700-line implementation plan.
It is utilizing the AI's vast knowledge base to expose the logical flaws in your own thinking before a single line of code is actually written. It saves hours of debugging later. The sources also address a very common, very frustrating problem called code bias.
Oh, this is a nightmare. Code bias happens when you ask Claude to add a shiny new feature to an app you've been building for a year. But your app's existing code base is messy. It has old, outdated functions and spaghetti logic.
We've all been there.
The AI reads your messy code to get context, and it thinks, this messy, inefficient style is how this developer likes to write. So when it builds the new feature, it intentionally replicates your terrible habits. It writes new garbage to match the old garbage.
The solution the senior devs use for code bias is surprisingly elegant, and it relies on the terminal's ability to manipulate files. When you need a completely fresh, highly optimized, innovative feature, you do not let the AI look at your existing code base. You use the terminal to create a brand new, completely empty folder. You drop Claude Code into that empty void and tell it to build the feature in pure, uncontaminated isolation.
You put it in a clean room.
Exactly. Because it has absolutely no bad examples to copy, it falls back on its baseline training, which means it writes clean, modern, mathematically optimal code. It builds the perfect version of the feature. Once the feature is working perfectly in that vacuum environment, you then instruct Claude to carefully migrate that pristine code back into your main, messy project directory and wire it up to the existing architecture.
It's like sending the AI to a quiet library to think without the distraction of your terrible past decisions. Okay, before we leave the topic of skills, I have to dive deep into what I think is the single most impressive cheat code from the entire stack of research. It's a complex, multi-tool workflow that combines Claude Code, local scripts, and Google's Notebook LM.
This is a phenomenal example of what we call orchestration. It's chaining completely different AI ecosystems together to save massive amounts of money while radically increasing your analytical power. Walk us through how they built this.
Okay, let's treat this like a recipe. Imagine you want to deeply understand a new software framework, and there are 20 hours of YouTube tutorials about it. Normally, you'd have to sit there and watch them. With this workflow, you open Claude Code and trigger a custom YouTube research skill.
What is the underlying mechanism of that skill?
The skill tells Claude to execute a Python script called YTDLP. For the non-technical folks, YTDLP is an open-source command line tool. It reaches out to YouTube, searches for the topic you asked for, and silently downloads the video metadata, the titles, the URLs, and crucially, the text transcripts of all the videos. It does this in seconds, without ever opening a browser.
And here's where the problem usually starts. If you take 20 hours of video transcripts and feed them directly back into Claude Code's terminal to analyze them, you will completely blow through your expensive API token limits in about 5 minutes. It's too much data.
Exactly. Thousands of dollars, potentially, just to read transcripts. But instead of reading them, this workflow introduces a clever workaround. It uses an unofficial Python API to securely connect your local terminal to Google's Notebook LM.
Which is free?
Notebook LM is a completely free tool provided by Google. Claude Code takes all of those text transcripts that just downloaded and automatically pushes them over the internet into a brand new, dedicated notebook inside Notebook LM.
What this does is turn Notebook LM into a free RAG system. RAG-G stands for Retrieval Augmented Generation. Let's explain RG simply. Imagine taking an exam. A standard AI model is taking a closed book test, relying entirely on its memory. A RAG-G system is an open book test.
I like that.
You give the AI a specific stack of books, in this case the YouTube transcripts, and say, only answer questions using the information found in these specific documents. Google's infrastructure does all the incredibly heavy, computationally expensive lifting of processing and indexing all that text data entirely for free.
So the data is indexed in Google. Then Claude Code, still sitting in your local terminal, sends a query API call to Notebook LM. It says, hey Google, read those transcripts and perform a deep thematic analysis. Extract the key trends, find the recurring coding patterns, and format the output into a structured curriculum.
And then Google responds.
Notebook LM does the thinking, generates the answer, and sends it back to your terminal.
The elegance is in the delegation.
It gets better. Claude takes that raw text analysis from Google, applies local formatting skills, and generates beautifully formatted markdown files, slide decks, or even handwritten blueprint-style visual infographics using local rendering tools. And the final assets are saved right into your local project folder. You get massive analytical output from 20 hours of video, beautifully formatted deliverables, and it costs you virtually zero Anthropic API tokens because Google's massive server farms did all the heavy text crunching offsite.
It is a completely orchestrated, highly automated research department running entirely from a black terminal window. It perfectly illustrates the macro shift we are seeing in the industry.
Yeah.
We are transitioning from using AI as a standalone tool that we manually operate to using AI as an intelligent orchestration layer that autonomously manages other software tools. And that evolution leads us directly, inevitably, into Part 5, Agent Teams.
Here we go.
This is the Opus 4.6 paradigm shift that has the entire software engineering world absolutely stunned.
This is the part of the deep dive where the sci-fi movies become reality. With the Opus 4.6 update, we have crossed a threshold. We are no longer talking to a single really smart AI assistant. We are literally managing an entire multidisciplinary digital organization. We have officially moved from commanding tools to leading teams.
The underlying architecture of these agent teams is staggering to comprehend. When you assign a massive, complex project to this system, say, build a secure messaging application, the system doesn't just try to process it sequentially, line by line, like older models. It spins up a shared, central, persistent task list.
It builds a roadmap.
It establishes a timeline. It constantly tracks dependencies, meaning it knows that the database has to be built before the login screen can function. And crucially, it establishes direct, private, peer-to-peer messaging inboxes between the different agents.
So here is what that looks like in practice. You have a supervisor agent at the top of the hierarchy. You give the supervisor the massive goal. The supervisor analyzes the goal, realizes it is too complex to do alone, so it autonomously spawns specialized subagents with specific parameters.
It builds its own team.
It creates a strategist agent whose only job is to plan the architecture. It spawns a copywriter agent whose only job is to draft the user-facing text. It creates a visual concept agent to design the CSS graphics, and it spawns a highly critical reviewer agent to act as quality assurance.
And you can actually watch this collaboration happening in real time on your screen if you use a specific terminal setup. The advanced tutorials highly recommend installing a terminal multiplexer called TMOX.
A multiplexer just means it splits your screen into different boxes, right?
Correct. TMOX allows you to take your single terminal window and split it into 4, 5, or 6 different distinct panes.
Yeah.
In each pane, you are watching the live terminal output of a different autonomous agent working in parallel.
It is mesmerizing to watch. You literally see the text scrolling as the copywriter agent drafts marketing copy in the top left pane, while simultaneously the visual agent is coding a complex SVG graphic in the top right pane. And then you see the reviewer agent jump in. It reads the copywriter's work, spots an inconsistency with the brand voice, and sends a critique message.
And the copywriter fixes it.
You watch the copywriter agent read the critique, revise the text based on the feedback, and submit it again. They are sending messages back and forth, collaborating, debating, and iterating without you, the human, ever having to touch the keyboard. It is literally a digital ant colony building a structure.
The architectural theory is fascinating, but the real-world results of this multi-agent setup are what truly cement its value and justify the hype.
Yeah.
We have to look at the C compiler masterpiece.
Yes, the C compiler story. This is the benchmark test that completely broke everyone's mental model of what AI was capable of this year. We need to explain this carefully so everyone understands the magnitude. Someone gave a team of Opus agents the goal of building a functional C compiler entirely from scratch.
Let's define what a C compiler is for our non-developer listeners. A compiler is arguably the most fundamental, complex piece of software in computer science. Human code, the words developers type, means nothing to a computer chip. A chip only understands electrical signals, ones and zeros.
Right.
A compiler is the massively complex translation engine that takes human-readable code and perfectly translates it into the exact machine code that a specific processor can execute. Building one requires profound structural understanding of how computer memory, logic gates, and operating systems function. It is not a website. It is the bedrock of computing.
And they told the AI to build this compiler using Rust, which is a notoriously strict, complex programming language. 16 parallel agents spun up. They worked autonomously, nonstop, iterating, debating, and testing. They ran for 2 straight weeks.
14 days.
14 days. No human was typing code or correcting them. The agents wrote 100,000 lines of complex Rust code, and at the end of the 2 weeks, they successfully compiled the compiler. They delivered a fully functional, highly optimized C compiler.
It is a towering achievement. But let's look at the economics, because that is where the true disruption lies. The compute cost, the cost of all those API tokens constantly firing between the 16 agents for 14 days, was roughly $20,000.
Which, to an individual listening to this, sounds like an insane amount of money to spend on an experiment.
It does sound high, but you have to view it through the lens of corporate economics. If a tech company wanted to build a custom C compiler from scratch, they would have to hire a team of senior, highly specialized systems engineers. They would pay them massive salaries, provide benefits, and the project would take 6 to 9 months. The fully loaded human capital cost would easily exceed $500,000. The AI swarm achieved the exact same high-level result in 2 weeks for 20 grand. The economics of software creation are being entirely upended.
And it wasn't just raw coding creation. Let's look at the cybersecurity case study, which might be even more impressive because it involves actual reasoning. An agent team was given some basic fuzzing tools.
Let's pause and explain fuzzing. Fuzzing is a cybersecurity technique where you essentially throw massive amounts of random, garbage data, unexpected characters, massive files at a piece of software to see if you can make it crash or behave weirdly.
Throwing everything at the wall.
It's like throwing a million randomly shaped keys at a lock to see if any of them accidentally turn the cylinder.
Perfect. So the AI team is given these fuzzing tools and pointed at a heavily audited, mature, open-source code base. They were given a simple directive: find unknown security vulnerabilities.
What is deeply fascinating here is the emergent strategic behavior of the agents. The AI team didn't just scan the current code using standard predictable patterns. They realized that bugs are created by human error over time. So the agents autonomously made the strategic decision to go back and read years of the project's Git commit history.
They read the historical save states. Why does that matter?
Because it allowed the AI to look at the evolution of the code over time. It wasn't just analyzing syntax, it was analyzing the human psychology of the developers. It looked at the history and noticed, 3 years ago, a developer pushed a massive update at 2 a.m. on a Friday right before a holiday weekend. They were rushed. They likely cut corners.
That is just brilliant. Because the AI took the initiative to read the history and understand the human context, it discovered 500 previously unknown, high-severity, zero-day vulnerabilities. 500.
In audited code.
In code that human security researchers and traditional automated security scanners had already cleared and stamped as safe. It was reasoning about time, pressure, and human error, not just looking at variables.
And then we moved from the lab into operational corporate reality with the deployment at Rakuten, the massive Japanese tech conglomerate. They didn't just test this in a sandbox. They deployed the Opus 4.6 agent architecture directly into a live 50-person human engineering organization.
This is where it gets slightly intimidating. In a single day, the AI agent autonomously analyzed the company's backlog and completely closed 13 complex engineering issues on its own, writing the code and pushing the fixes. But that's just coding. What it did next was management.
It became the boss.
It analyzed 12 other highly complex issues that required human intervention. It then looked at the company's internal org chart and project history. It understood exactly which human engineers had the correct historical context for specific obscure subsystems, and it automatically routed and assigned the tickets to the right human beings.
It wasn't just acting as a senior developer. It was acting as an engineering manager. It understood human organizational dependencies and workflows. If an AI swarm can autonomously handle the coordination, triage, and assignment work that typically consumes 20 hours a week for a highly paid human engineering manager, the very definition of corporate management is about to undergo a radical transformation.
But look, I know some of our listeners are sitting there thinking, this is fascinating, but I don't care about C compilers. I'm not a cybersecurity researcher, and I don't manage 50 engineers. How does this apply to me?
It applies.
It applies to you because of what the agents enable. We are entering the era of what the tech community is calling vibe working and personal software.
This is perhaps the most profound cultural shift for the general public. Let's look at the Monday.com case study. 2 non-technical reporters, people with zero computer science background, used the Claude Code agent system to build a fully functioning clone of Monday.com. For context, Monday.com is a multi-billion-dollar project management software. It has complex calendar views, dragging and dropping task boards, automated email integrations, and database syncing.
A huge app.
These two reporters built a working clone in under an hour, and it cost them about $10 in compute tokens.
And they were able to do it because of vibe working. This is the final evolution of the Minecraft creative mode analogy. You no longer have to describe the process of how to code a database. You don't have to know what a SQL query is. You just describe the outcome.
The vibe.
You say to the agent, I want a project dashboard. I want it to look sleek and dark themed like this screenshot. When I click this blue button, I want it to send an email to the client, update the calendar, and move the card to the done column.
The AI acts as the translation layer. It figures out the complex mathematical formulas, it wires up the API data connections, it writes the CSS formatting, it provisions the database. You are simply the director. The AI is the executioner.
Yeah.
You just point at the aesthetic or the vibe you want, outline the business logic in plain English, and the software manifests in front of you.
Software is no longer a static product you buy a subscription for. It is becoming a fluid, localized material that you generate on demand to solve a hyper-specific personal or business problem. If you need a custom app to track your family's obscure dietary restrictions, you don't search the App Store. You generate it in 10 minutes.
It completely democratizes creation.
It is absolutely staggering. So let's take a breath and bring this all together. What an insane journey this has been today. We started with the very real fear of the terminal understanding why we have to leave the browser, learning the basic keyboard shortcuts, and setting up that crucial login trick so we don't lose our work.
The foundation.
We moved on to mastering context crafting, that lean essential Claude.md onboarding file so the AI doesn't suffer a lobotomy from context rot. We talked about engineering robust multi-step skills with progressive disclosure and MCP protocols. We explored how to link tools together like Notebook LM to bypass token costs. And we ended by looking at the reality of orchestrating multi-agent teams that are literally building enterprise software, finding zero-day hacks, and managing human developers while we sleep.
And the single overarching takeaway that every listener must internalize from this deep dive is the terrifying, exhilarating velocity of this evolution. Going from an AI agent that loses his mind after 30 minutes of simple coding to a swarm of agents collaborating perfectly for 14 days straight to build a compiler, that leap happened in less than 12 months. As we sit here right now in March of 2026, whatever mental model you had of what AI was capable of back in January is already completely obsolete.
You cannot rest on what you knew 2 months ago. You have to keep pushing, keep testing, keep breaking things, and keep building. Which leads us to a final provocative thought to leave you with today, something for you to really mull over as you close this out and open your terminal.
We have spent an hour talking about the specific workflows to act like a senior developer or a manager using AI. But you need to deeply, philosophically rethink what those job titles even mean in the 2026 economy. If hierarchy, delegation, code review, and management are naturally emerging natively within these AI swarms, because management is simply what intelligence naturally does when it needs to coordinate complex tasks at a massive scale, then what exactly is your unique role in the organization of the future?
Right. If the AI is perfectly capable of managing itself, debugging its own code, and routing its own tickets, what are you managing? Here's the challenge I want to leave you with. As we move forward, the critical metric of your career success, your personal value, is no longer how many human beings sit beneath you on an org chart. It is not how fast you can type boilerplate React code. The defining metric of the next decade is your personal agent-to-human ratio. In a world where raw technical execution is infinite, autonomous, and nearly free, your typing skills do not matter. The only human qualities that scale are your creative taste, your strategic judgment, your empathy for the end user, and your ability to clearly, flawlessly articulate intent to a machine. The question isn't whether AI will do the work. The work is already being done. The question is, how many agents are you ready to lead today?
Start building your team. Open the terminal.
Thanks for taking this deep dive with us. Keep building, and we will see you on the next one.